This is the webinar series which we are presenting, and this is a 4-day webinar series. So it is on the 2 weekends, that is 9th and 10th, that is this weekend and the next weekend, which is 16th and 17th of July. And the sessions are of 1 hour each, and they would be packed with knowledge from speakers across various domains, across like with great knowledge, who would come and impart everyone with great ideas. So for today, our speaker is Anindita Desarkar, ma'am. So hello, ma'am.
Yeah, hi. Yeah.
So Anindita ma'am would be speaking on the significance of outliers in data science. She has been a dedicated researcher and a IT professional with more than 18 years of experience in the industry in the multitude of domains of machine learning and data warehousing. So we are glad to have her here, and I think, ma'am, you can start this.
Okay. Yeah. Thanks for giving this wonderful opportunity. Thanks to all of you for joining. So I'm just sharing my screen. Let me know. So kindly let me know whether you're able to see my screen.
Yes, ma'am, it is.
So our today's topic is significance of outliers in data science. So I think all of you, I mean, some of you may, are familiar with the word outlier. Like it's not only data science, basically outlier are important in our day-to-day life. I mean, everyday's life, outlier is a very common word. So today we'll see few of the things like what is outlier and what kind of outliers can exist in nature, in data science, in everywhere, and also like significance of outliers, like what the outliers mean exactly, and how, what insights we can get from the outliers, or whether outliers we have to remove, or outliers can give us any specific value. So all these things we will see basically what's the significance of these outliers, and definitely what are the outlier detection techniques both in statistical domain and also machine learning domains. So these things we'll try to explore in the today's sessions. So this is the first one. You can see few pictures are there. So I think these are everybody can understand. So this is just a road picture where everybody is just walking and one person is just going through the cycle. And this is a second picture where others people are just moving or walking and another one car is only there. So from this picture, all you can understand what are the outliers. Basically, outliers are the objects which are dissimilar in nature from other set of data. So from this picture, it's very clear that this is the outlier, and this picture, this is the outlier. So what are these identified entities basically? These are the outliers and why they are different. Basically here from here we can easily identify, that's fine. But when we do some, how we can identify that? By some image processing techniques, right? Like image processing techniques or some video analytics techniques, we can identify that one. But what are the ways to identify the entities? So first thing is that what are the outliers and how we can identify the outliers, and also what is the significance, because what we'll do by identifying those outliers. So all these things we'll see. So another example you can see here. So it's a network traffic. You can understand like these things, what it says, like we in the network traffics, that intrusion detection is there because few signals are there which are basically hazardous. So definitely some alert generation, those techniques should be in place. So this is the significance basically, because this few signals which are basically hazardous or very dangerous for the full network, so we need some alert generation technique. So this is the significance of outliers, because this should be removed, but or this should be identified basically. This should be identified for, because these are dangerous, all these things, because this can be some significance of some attack or something. Basically, this is attack recognition. So from this, we can identify the attacks. This is the significance of outliers here. So here you can understand this intrusion is the outlier in this network traffic domain, and how I need to identify that. So to identify any means we can just predict some upcoming attack or something. So this is the significance. So this is what is outliers. Now you understand all, like this is an anomaly in data. So which is basically dissimilar in nature from other parts of the data. So it can be any type of anomaly, but from we will try to identify that anomaly from the data, because that is the some significance is there. It may be some used for some good purpose, or this should be removed to get the clean data. So whatever the case, positive or negative, this has some significance. So whatever outliers we see, whatever outliers exist in nature, broadly we can classify it into three types. So first thing is the global outliers or point anomalies. So what is global outlier? This is a very common type of outlier. Basically, this is outlier in global nature. Any kind of normal outlier, like that is basically irrespective of time, domain, or anything, this is outlier. So you can see any exceptional, that previous example you have seen, right? That computer network. So some behaviors or signal behavior is exceptional compared to the other signals. So those are the outliers, and those are global outliers. So it is basically irrespective of time, context, irrespective of country, anything, those are outliers. Basically, those signals should be treated as outliers. So those are the global outliers. This is type 1 and most commonly used outliers. And this is also called point anomalies. This is the first type. So what is the second type? Second type of outlier is that the third type. Second type is that basically contextual outlier. Second type is the context. What is contextual outlier? Contextual outliers are the outlier which are basically for a specific context. Those are called outliers. What is the example? If I say today that today's Kolkata, I mean, temperature of Kolkata is 6 degrees Celsius. So why it is called contextual outlier? Because in Kolkata, 6 degrees Celsius is very, very abnormal, but it is not abnormal in Himachal Pradesh or in Darjeeling. So basically in the context of Kolkata, this is called as outlier. So this is the second type of outliers, that is contextual outlier. So for a specific context, we'll call the data as outliers. So the third thing is the collective outlier. So that is also not very common, but it exists in nature. So that is a subset of data point anomalies when compared a collection with the entire data set. So a very common example, all you can correlate, that is in a class for a specific year, maybe a bunch of students has failed. So maybe out of 80, like 40 or 50 students failed in the exam. So maybe it's not an outlier in the total set, but the thing is that for that for a total set like 40 or 50 can be called as the outlier, because collectively those data is outlier, but not a single point. Because if we consider 80 students data and 50 students data are below 40, that should not be called as outlier. But collectively, if we see that 40 or 50 students data is a outlier, so this is called collective outlier. So in nature, it's not in data science. In nature, basically, you can see in nature or whatever in our day-to-day life, all data, all the outliers, if you just see, there will be these three types. First is the global outlier, that is point anomalies. That is very common. That as we have seen, that is basically irrespective of anything, that is called outlier. Second type is the contextual outlier. For a specific type or specific context, that data point is treated as outlier. And third one is the collective outlier. So collectively a set of data is called outliers. So whatever example you will see in nature in our day-to-day life, all the outliers belong to these three types. So this is one classification basically. How we have classified that one? Basically based on the context, we have classified into three types. So another type of classification can exist, that is based on the behavioral aspect. So how the outliers behave. So in that aspect, there can be two types of outliers. What can be the positive outliers and another can be the negative outliers. So what is positive outliers? Basically, positive outliers are the values which exist beyond the upper limit of the boundary level. Those are called positive outliers. And negative outliers, definitely values that is lying below the lower limit of the boundary level are called the negative outliers. So we have seen two classifications of outlier. One is context based. There basically three types exist, and another was the on behavioral aspect. There are basically two types of outlier exist. One is positive and negative. So these are the common type of outlier exist in nature. So if you can see in another other examples also, everywhere you can see these three types. Maybe the global outliers are more in number, that is more common, but other two types also exist. So if we, because as we have seen, outliers are present in every domain, everywhere. So no domain is the exception. Basically, everywhere its presence is there. So few domains, if we see, one is the security domain. Security domain, what is one outlier can be? That is the presence of inconsistent and forged signature basically in the training data set or any data set. And basically one test case we have done in security domain, that is the finding the forged signature in the training data set. So what was our objective of doing that? What is the significance? So what we have seen basically in the training data set, a few outlier signatures exist. So first we have found the signature identification accuracy. And in that, in the first time, we have considered all the training data set, including the outlier signatures. But after that, we have removed the outliers, I mean the outlier signatures from the training data set. And then again, we have just calculated the signature identification accuracy. So after removing the outliers, what we have seen, definitely the identification accuracy has improved. So this is the I mean significance of outliers, because after removing these outlier things, we can see the accuracy has been improved. I mean signature identification accuracy has been improved. So this is one very good example of significance of outliers in security domain. Second can be one another domain. Definitely there are more other examples in security domain that you can correlate everywhere. And another thing can be another domain, common domain. So everybody, I think you are familiar, you can more familiar with this domain, that is education domain. So there can be different outliers if you see. So there can be outperformer, there can be poor performer, that is maybe some outstanding faculties are there, maybe some outstanding institutions are there. All are the outliers basically, maybe in the positive sense, maybe in the negative sense, but all the cases they have some significance. So basically what is the significance? If we see some outperformer students are there or outperformers faculties are there, basically we try to identify what are the qualities they have, what are the qualities they have, why they are outperforming the more than others, so that others can basically see this, or others can basically I mean follow that, so that other students or others, all others can be benefited from that. So these are the significance of the those positive outliers. And on the other side, if we see the negative outliers, what is the significance? Definitely. So we will try to identify if some students are getting poor marks, or in some institutions are not performing good. So we try to identify why they are doing that. So these are the analysis of outliers. First, you have to identify basically what are the outlier things, what are the outlier institutes, or what are the outlier ones. So then we'll see in what features for they are basically residing in the outlier domain. So, and in this way they will be benefited because they will get the chance to make them better. So these are the in education domain. So different outliers are there in the education domain. And the third, another domain, another very important domain is the healthcare domain. So healthcare domain, how this thing works, because you know, like all these, I mean, patient report, everything, if we do the analysis, and if we can early prediction of diseases from those reports, from those X-ray report, or from other reports, basically, so definitely we can give the early prediction of diseases or any fatal abnormalities. So to improve the mortality rate, because uh, you understand there are two kinds of things can be there. One kind of the X-ray kind of reports, one is the abnormal report in text form. So there are, you know, like NLPs there, computer vision, all domains are there. By getting help from those two domains, we can identify the outliers, like some some specific words are present in some patient's report. So if we can identify those can be treated as the outliers. Those patients are the treated as outliers. So we can give some early prediction or early alert to them, so that they can basically in the near future they can basically cautious of the other things. So these are the basically significance of outliers in healthcare domain. So you can see in each and every domain is not restricted to these three domains. Just for example, just I have given these three domains. Every domain, everywhere, this outliers has a great significance. Everywhere is important, and it is both way. As I have told you, it is both way. It's not that always you can see here. Always you don't have to remove the outliers. So outliers are not always bad. Some cases, if you remove the outliers, basically you can gain accuracy, you can gain something. But in some cases, outliers are the specific thing. Outliers are the things we want to identify, that you have seen in the security domain or in the that network domain. You have seen, right? Outliers are the basically messenger of something, because those network traffics which are the outliers, basically those are the alerts. So the outliers has the great significance. And in education domain also, like outperformance, those are the outliers, and those has the great significance. So outliers are important in two aspects. One is outliers itself has a great significance. If you remove them, the data accuracy can be improved, and also those outliers, after doing the outlier analysis, we can get some very meaningful important insights. So any question till now? Okay, so we can proceed, and after that we can see if any question is there. So these are the things what we have already seen. These are the different outliers in various socio-economic domains. You can see we have discussed that intrusion detection, fraud detection, and fraud detection can happen in all the cases, like mobile phone, it can be insurance claim, it can be credit card. So all the fraud, what are these frauds? Fraud detection, what we'll do, these are the outliers basically. In a big data set, in a large or huge data set, those are the data which are the outliers. Those are the fraud data. So those data has the great significance. And this is similar cases in the medical and public health also, in image processing. So everywhere the outliers has the great significance because they have a special meaning. So now, till now, we have seen what are the outliers and what is their significance. Now our question is that how we can identify the outliers. Definitely there should be some specific techniques, tools and techniques which will help us to identify the outliers. And there are different techniques are there. So we'll see today few major techniques, or few, basically easy and very common techniques that you can easily implement in your daily day-to-day life, or in your daily projects to identify the outliers. So one is the statistical tools and techniques. So what is there in the statistical tools and techniques? Again, there can be different types of techniques can be there based on the nature of data. So one can be based on the some techniques we will see that is based on the univariate data, means that data is one dimensional. Second, few techniques exist based on what can be basically applied on bivariate data. Basically data is two dimensional. In and third case, basically it can be multivariate data. Data has multi-dimension, that is more than two dimensions. So we'll see those statistical tools and techniques. And except that also many machine learning techniques are there. I think you are familiar with the machine learning. So basically in machine learning, different techniques are there to identify the outliers. So then there can be proximity based technique, can be isolation forest, some neural network based techniques, rule based techniques, all are there. So we'll see few of the techniques today to how to identify how to detect the outliers. So first one is the univariate data. How we can do in the univariate data. So you understand univariate data is nothing but data with one dimension, like X, only X axis. One dimensional data is called the univariate data. So what we can identify do in the univariate data? Majorly four types of techniques are there, and definitely more than these four other techniques are there. One is the very Dixon test and graph text. These are very old technique, but these are the just listed down because you can understand from there the outlet detection started. But nowadays, commonly used techniques are the Z-score, and box plot and interquartile range, I mean the IQR technique. We'll see these two techniques that is most common and widely used. One is the Z-score and second is the basically IQR based technique. So what is Z-score? Z-score is probably a simplest algorithm basically that rapidly screen the candidate items for further analysis. Again, we have seen that is applied on the one-dimensional data. Data has one dimension. So basically, it is a statistical measure which demonstrates how dissimilar data point is from rest of the data set. A specific data point, how it is dissimilar from the rest of the data set, or how will detect it, how many standard deviation away a given observation is from the mean. Basically, that is the definition of the way we calculate this one. So if you see the calculation, Z-score equal to x minus mu divided by sigma. So what is this one? X is the your data point. Suppose you have one column length is there. One column just length is there because it is one dimensional data. You have 5 feet 3 inches, 5 feet 6 inches, 5 feet 7 inches like that. And another column you are creating Z-score column. What you will do? X is the your data point like 5 feet 3 inches. For the first row, your value minus mu. Mu is the population mean, just the mean of the data, and divided by the standard deviation of the population. So for each and every data point, you will get the Z-score. For every data point, I mean for every row, you will get the Z-score. And from that, you will identify how will now your Z-score is identified. Now, how will see the outliers? Now the point is that for the Z-score values for the data points for whose Z-score value is beyond plus 3 and minus 3, those are the outliers. This is a very simple technique to understand. For the one dimensional data, you have one basically column because it's one dimensional, and you will create another simple column. So those are the Z-score, and the formula is very simple: x minus mu divided by sigma. So you will get the Z-score. And how will identify the outliers? The values which are beyond plus minus 3, those are the outliers. So those data points are the outliers. So this is our first method for the univariate data. And another very common technique is that by the IQR, that interquartile range technique, that is also applied on the one-dimensional data. So how we'll do that? For that, we need a few specific measures first we need to do on the data set. So what first we'll identify the median of the data, then Q3 that is 75 percentile, Q1 that is 25 percentile, and also maximum. What is maximum? That is Q3 plus 1.5 into IQR. And what is IQR? This Q1 to Q3. This is the IQR value. So you find the maximum and this is the minimum. What is minimum? Q1 minus 1.5 into IQR. So in this IQR, basically 5 measures are there. Total 5 measures are there. You can see from this picture. One is the first median, then Q1, Q3, and then minimum and maximum. What is minimum and maximum? You can see, and the points which are basically lies outside this minimum and maximum, those are called the outliers. So you understand this is the measurement. How we'll identify the outliers in the data set by this IQR methodology. So the data points which are basically greater than this maximum, those are called the positive outliers. Means which data points which are basically greater than Q3 plus 1.5 IQR range, those are the positive outlier, and which are basically less than this minimum Q1 minus 1.5 into IQR, those are the negative outliers. So this is the second method. I mean what we have discussed, and this is also very common and very commonly used method for detecting outliers, and definitely it is on one dimensional data. And what you have to do, you have to find the these 5 measures for the that specific data set, and based on that you will find your outliers. Very straightforward technique you can easily utilize for any of your project or any of your calculation where it is one dimensional data is there. Now these are the things we already discussed. These are the 5 measures by which you can find your outliers. Now till now what we have seen, that is all one dimensional data. but definitely we have two-dimensional and multi-dimensional data. So in two-dimensional data, one very important or I mean popular technique is that finding outliers based on the regression curve, and based on this basically regression and this regression technique, basically we'll find the outliers. How we'll find the outliers? So this is you can see here uh, what is there in the regression curve. So these are the student weight. Suppose these are the student weight is basically in the x-axis, and backpack weight is there in the y-axis. So these are the we have plotted data. This has two-dimensional data. You can easily see for these two students or these two persons, those are the outliers. Why? Basically, those are much. I mean, these are dissimilar in nature, because in other cases you can see if student weight is there and some backpack weight, that is also increasing, something like that. But in the two cases here, student weight is increased but backpack weight is not increased. In case of Sharon, the opposite thing has happened. So these two data points are the outliers, I mean, based on the other data points in the set. So from this I mean scatter plot, this is scatter plot, you understand, this is a visual representation that which shows the relationship between two numerical variables. So from this we can easily identify if data point is detected as outlier if it does not fit into the pattern. So these data points, two data points, are not fitting within the pattern, so definitely those are called outliers. So definitely another thing, another concept is the correlation, you understand. So this is positive correlation, this is negative correlation, means within this data point some relationship exists. But if this data point is here itself or here itself, you understand, those are not correlated because no relationship exists. So basically those are the outliers. This is another concept. And another very important concept is that is based on the regression line. So how you find this one? From the regression line, basically a data point, how much distance it is from the regression line. So if you just create a regression line here, if you create a regression line here, and suppose the data point is there, and if you find the perpendicular distance from this data point to the regression line, and based on the distance, basically you can find whether it's an outlier or not. So definitely if the data point is here, it may not be treated as outlier, and but it is here, but definitely you have to maintain some threshold. Based on that, you will say whether the data point is an outlier or not. So that is basically how we'll do that. You find one regression line and find the perpendicular distance from the regression line to the data point, and based on the distance you can find whether data point is outlier or not. So till now we have seen those are the majorly are the statistics based techniques. I mean the statistical techniques which are by which we can find the outliers. Now we'll see a few machine learning techniques which are very useful to find the outliers. So one is the, you know, in machine learning, a major few classifications are there. I think somebody, you know, if you does not know, just giving a brief introduction. Like in machine learning, majorly two categories are there. One is the supervised technique and another one is the unsupervised technique. So in supervised technique, what happens? You have the training data set. You have label training data set. So based on the label training data set, you can find your model, and whatever new data set or new things if you get, so based on your data model, it will predict that one. So that is the supervised method. And in case of unsupervised method, basically no training data set exists. Only no label data set, nothing is there. Only you have a data set, but no label, nothing is there. Based on clustering, based on some other technique, you have to find the insight. You have to find the things. That is the unsupervised approach. So under supervised, different algorithms are there, and under unsupervised also different algorithms are there. So in supervised technique, so one very common algorithm, common and very easy, is the KNN, that is K nearest neighbor algorithm. This is a very simple supervised algorithm which stores all available training tuples till a new data tuple arrives for testing. So how KNN works? So this is the basic way how the KNN works. Like the input to a KNN model consists of the whole set of the training data set available, and usually stored in the form of a feature vector representing each data point uniquely. So it has the whole set of training data set. So whatever you are getting in the training data set, it stores in the form of feature vector representing each data point uniquely. In the second stage, what it happens in KNN classification, basically you are classifying your data, classifying whether it is a normal data or it's a outlier data. In this way, basically you will identify the outliers in KNN. Basically, KNN is a classification technique, right? KNN is a classification technique. Suppose you have your data set, you want to find out like red marbles, blue marbles, and green marbles are there. Those are the, you have to classify your data set. So suppose three classes are there, but in the same way we are identifying the outliers. How? One is the one, then there will be the basically two classes. One is the normal class and another is the outlier class. So how we'll do that? In KNN classification, output is determined by a majority vote of its nearest k neighbor, with the object being assigned to the class most common here. And if k equal to 1, then object is simply assigned to the class of the single nearest neighbor. So by this way, we'll do the classification. And as I told you, it can be used for the outlier detection. How? Basically, in that case, two classes will exist. One is the normal class and one is the outlier class. So, and this can be used for both classification and regression. In case of regression, what happens? The output value of the new object is ascertained as the average of the output values of the k nearest neighbor. So in that way, KNN can handle both classification and regression. And KNN by KNN, we can find the outliers. So basically always is the classification algorithm. But as I told you, this is outliers can be treated as a separate class, like normal class, normal data set, that is the normal data set is there, and which are the outlier data that we can call a separate class. So in KNN, we can create two classes. One is the normal class and one is the outlier class. So by KNN, we can easily find out the outliers. So that is the second class, that is the outlier class. So this is the supervised technique. Now another technique we'll see, that is the unsupervised technique. So what is unsupervised? As I told you earlier, so where your training data set is not available. So in the first case, KNN, we have already seen we have the training data set. I mean label training data set is there. So you can easily find your outliers because you have the model. You have your training data set with label training data set. You have created your model, and when you get a new data set, you can tell whether it is a normal data or a outlier data. But in case of unsupervised technique, you don't have the label data because your training data set is not labeled. So how will do? You have a suppose multi-dimensional data set you have, because in real scenario, most of the data set are multi-dimensional. More than 2 dimensions are there, and it is not labeled. So in that cases, density based spatial clustering of application, or DB scan, widely known as DB scan, that can be used for the identification of outliers. So how we can do that one? So this is the very common picture. If you see in the outlier in the this DB scan, what we'll do, we basically find the clusters. We can create the clusters. We have the mechanism by which you can create the clusters. So you can see these are the clusters. And so different data points are there, different classes are there of the data points. One is the data points which basically can be used as the border. So another is the code data point. So the clusters are grown based on the density factors depending on the above two criteria. Each object is either marked as a core point. Each object means your value in the data set, your basically data, that is called as a code data point or a border data point. And few data are there in your data set which basically does not belong to one of these two classes, core or border classes. Those are called as the outliers. So you understand how you have to detect the outliers. Basically, in your data set, you will apply the DB scan technique, and you will get your border classes, basically the data point which are in the border line, and your data basically which are the code data points, and which basically does not reside one of these, that is called the outlier data points. So this way we can identify the outliers. And how we can identify that in DB scan, these are the very two important measures of DB scan. DB scan technique. One is the EPS because you don't have the label data. So how will do that one? One very two important parameters are EPS, that is the epsilon, that is a neighborhood around the data point. 2 points are considered as neighbors. The distance between them is the lower or equal to EPS. So here this is the basically your I mean this is the this radius, that EPS is the your basically EPS, that is the radius from this center to this data point. This is your EPS. So that should be chosen very carefully. And another point is that minimum points. So when you are creating your cluster, that defines how minimum number of points required within EPS radius required to mark the region or dense. Higher values of minimum data points should be chosen for large data set. So this is a basic thumb rule is there, how we have to choose your minimum data points. So based on different rules and based on different experiment, basically we choose the minimum points in our data set. So these are the very important two things, EPS and minimum points, to create your DB scan. I mean, basically in your when you are creating your DB scan model, you have to pass these two parameter, epsilon and minimum points. So based on that, you will create your DB scan. You will run your DB scan model. So this is a machine learning model, and how when it will be used, as I told you, it is for the unsupervised data set where you don't have the training data set. You don't have label training data. So you have to use the some unsupervised technique where this DB scan is a very commonly used one. And how you create your define your outlier, or how you find your outlier here. So you will find your border points and core points, and the points which does not reside with this border or core points are treated as the outlier points. So these are the your outlier points. So these are the different things, different ways how can we detect the outliers. So if we summarize till now what we have seen, what is outliers? Definitely we have seen outlier. What is outlier? This is some data point which are dissimilar in nature from other data points in the data set. So this is called your outlier. Second thing, what we have seen, what are the different type of outliers in nature? That again, two ways we have seen. One is context-based classification. So what are the context-based classification? That is global outlier or point anomalies, which are very common in nature. Global in, outlier in every sense. Second is contextual outlier, that is outlier in a specific context. Third is the outlier in overall, basically. Third type of outliers, collective outliers, basically. These are the three outlier types in nature. This is the types of outliers. Next thing we have seen, that is the based on the nature of outlier, that can be positive or negative outliers. Basically, these are the classification of outliers. Now, what we have seen, what are the outlier detection techniques? Basically, now we understood why we have to identify the outliers. So there are different techniques exist in data science or in statistical domain in data science. So by which we can identify the outliers. So first we have seen few statistical based techniques and then few machine learning based techniques. In statistical techniques, we deal with three types of data. One is the univariate data, second is the two-dimensional data, and third is multivariate data. So univariate data we have seen like a J-score or box plot are the different ways to find the outliers. In case of two-dimensional data, we have seen that we have those techniques like the scatter plot analysis or all these things for the two-dimensional data. And for multi-dimensional data, we have different machine learning techniques. Again, that is classified into two types. For supervised, there are different techniques, and KNN is one of them. And for unsupervised, again, different techniques are there. So out of this, like DB scan is a very common one. And except this also, like we have isolation forest and many other techniques are there. So these are the basically gives you the introduction of what is outlier and what outlier means, why we have to detect the outliers, and what are the different outlier detection techniques in statistical domain and both in the machine learning domain exist. So now this is the things we have seen. Kindly you can tell me if you have any doubt, of any clarification, or if you have any question is there. Or if you want me to explain any specific slide, that is fine. Or if you have any specific question, that is also fine.
Attendees, you can ask your questions via the chat box as well if you have some problems with your microphone.
So we don't have any questions. Participants, please, you can ask your questions to for ma'am in the chat box, please.
Yeah, the floor is open. So, and ma'am will be answering any of your doubts, or maybe if you want her to repeat anything, she can do that as well.
So may I know? So I mean, in any of you have used any machine learning projects or something? So yeah,
Thank you, Anindita. Dr. Goje here. You have explained it very well about the outliers, and I think student must have understood the examples, whatever you are given, and even the application areas. And you rightly pointed out that they should come out with some small mini project kind of things. And
yeah.
that too, they should apply both the technique. First, they should go with statistical techniques, and then they should go with MIML techniques, so that they can have relevance of which technique should be used when and all. So this is really nice, and I'm happy that you came with short notice and deliver this lecture. Thank you very much, Anindita.
Yeah, yeah. Thank you, sir. Yeah, yeah.
Ma'am, actually, we have a question here. So, the question says that what is the importance of outliers in the domain of generative models?
Yeah, in every, as I told you, in every domain, it has some importance. So could you please elaborate in generative models? What basically generative model is one kind of model. Okay, so domain is the basically as we have discussed already, like education domain, security domain, those are the domains. So and again, every domain has its importance, and models are there are different models, like we have seen some statistical model, some machine learning models. So by few models, different models are there by which you can detect the outliers. So domain is the thing where the outlier exists, and models or techniques are the things basically where you will by which you will identify the outliers.
Okay, ma'am, I think you have answered the question.
No, it's
And
very important that she rightly pointed out the domains are the application areas. She mentioned that health, agriculture, your government domain, maybe n number of areas, whatever exist. Even if you can ask me, a satellite is the domain area.
Yeah, yeah,
So you decide which domain area you want, and then you want to decide which model is appropriate for that domain, and then decide how to detect the outliers. And she rightly pointed out whether they are positive outliers or negative outliers. So and this is a huge area of research. If you ask me, even if you few students are with their families are into businesses and all that, for you this is a very interesting area. If you can find out some outliers in your day-to-day business activities, and then you can apply, because you have data available with you. Instead of going into in another application, the data set is with you yourself. So you can find out outliers even in finance domain. In fact, finance domain, there are huge applications of outliers. So look into that. And she rightly pointed out that you should find out the application areas around you in which you find that you are having sufficient data set with you. So sometimes what happens, we are behind data sets. We are trying to go to Kaggle, we are trying to go to other data sets, and we forget that data set is with ourselves. It is there. So if the people, those who are from family businesses, I think you should have more relevance and you have a lot of data with you. Thank you.
Yeah, yeah. So
So,
thank you. Yeah.
okay, so ma'am, if you could like stop sharing, then
Sorry.
if you could stop sharing the
Yeah, yeah,
screen.
yeah, yeah.
Okay, so thank you so much, Anindita ma'am, for giving us time, as you know, Shoptotri sir and Goja sir said, in a very short notice. Like it has been about 2 or 3 hours since we contacted you.
Yeah,
So
yeah, sure.
it has been a pleasure to have you, and I think the attendees have learned a lot from your talk. It was packed with knowledge and information on outliers, and it was very exhaustive, covering everything. So thank you so much.
Yeah, thank you. And thank you to all of you
Thank
for
you.
attending
Thank
this one,
you.
and a very wonderful opportunity. I mean, wonderful platform. I mean, talking regarding this. So I'll be happy to take in more. And if somebody has any problem in project regarding outliers, so I'll be happy to collaborate with him or her.
Very nice.
Thank
Very
you
nice.
again.
Thank
Yes,
you.
ma'am.
Thank you, Anindita.
Sir,
Okay.
can you? I would request Amol sir to present the token of gratitude to Anindita ma'am.
Yes, yes, definitely. Thank you very much, Anindita, for joining with short notice of time, and thank you for my student chapters and the efforts that student chapter is taking. And I see that attendance is also good, means that shows that our student chapters are active. And she rightly pointed out she is ready to help our students with small projects and all that. So, so kind of you, Anindita. Thank you very much.
Yeah, thank you, sir. Thanks everybody for joining.
And another thing for the attendees, as we had mentioned that we would give certificates. So the attendance link is given in the chat. So maybe you all can fill it up, and the certificates should be mailed after the end of the webinar. And if we can have a small snapshot with everyone, with their cameras on, for those, it it's possible. If you can, open your cameras, that would be great. Another thing, did everyone get the attendance link, or should I share it again? Okay, it has been given again in the. Okay, I'm sharing it once. Just give me a moment.
So thank you, Soumyadeep. I think we should leave.
Yes, sir, we'll just have a snapshot.
No
Just
problem. Thank you.
if you
So we'll
can.
meet
Oh,
tomorrow.
yes, sir.
So I would like to announce one thing to the participants, that tomorrow we will have 2 sessions with 2 speakers on board, and we would like everyone to join. And please do, before leaving, please do fill up the Google form, because you won't get the certificates without that.
Yeah.
And ask your friends who are absent today should join. These are very good lectures and informative lectures. Definitely, they will help us in your future.
Tomorrow we'll have 2 sessions. One would be on importance of research for undergraduate students, as most of us here are undergraduate students.
Very
So that
nice.
would be very pertinent to our age group. And the second one would be how machine learning and data science is leveraged in large companies. So that would also be a very interesting topic. So I'd request everyone to join tomorrow, and ask those who had registered and haven't joined today to join tomorrow. Thank you so much.
So Nirmala, I think that brings us to the end of today's session.
Yeah.
So thank you so much, ma'am, Amol sir, and Shoptoshi sir, everyone for joining, and all the participants for joining today. So we would like to see you again tomorrow at the same time.
Thank you.
Yeah, thanks
Thank you, sir.
everybody. Thank you.
Have a
Thank
have
you.
a good day.